Hello students, in this video I'm going to discuss a question from mathematics. This is a question from IIT JEE Advanced 2024. See, this question is, it looks as if it is a question from limit, but actually it is a question from differential equation. This question can be done in various ways. So here I'm going to discuss uh, one particular solution which is based on differential equation. Okay. So let's see. The question says fx be a continuously differentiable function on the interval 0 to infinity, such that value of function at x equal to 1 is 2. Okay. Now it says limit for this term is equal to 1. Limit t tending to x. Okay. So we have to find fx. Fx is equal to. So this function is to be found. Okay. So if you here put see t is tending to x. So if you put in place of t, you put x here, you are going to get here 0 by 0 form. This is going to give you 0 by 0 form. Okay. So therefore, we can use here L'Hospital's rule or L'Hospital, whatever it is called. Okay. So let's use L'Hospital rule. Okay. So therefore, what I'll do is, see, limit is being taken on x. So we'll differentiate both numerator and denominator with respect to x here. Sorry, with respect to t, because limit is being taken on t. So let's differentiate it with respect to t. So if you differentiate it, see what you are going to get here: 10 t to the power 9, and this f of x will remain as it is because we are differentiating with respect to t here. We are applying here L'Hospital's rule. Yeah, so this I'm applying here. Okay. So let's differentiate numerator with respect to t. It gives you 10 t to the power 9 fx minus, since we are not differentiating x here, so x will remain as it is and it will become f primed t. Okay. And when you differentiate numerator, you get here 9 t to the power 8 minus 0. That is equal to 1. Okay. Now here we have to take limit. We are taking limit here, limit t tending to x. So let's put x in place of t here. So if you do that everywhere, so you are going to get here x to the power 9. Here there is x to the power, x to the power 8, x to the power 9, and x to the power 10. So you get here basically 10x and f of x and minus x square and f primed x. That is equal to, here we have cancelled the x to the power 8 factor here. So 9 gets multiplied with 1 and you get here 9. Okay. So this is a first order differential equation now. Okay. We can solve this differential equation. So let's rewrite it. We are multiplying it by minus 1 and dividing by x square. So if you do that, what you are going to get here is this. See, you are going to get here f prime x. Okay. Minus, when we multiply by minus 1, it becomes minus 10 and divide by x square. So it becomes 10 by x and f of x. Okay. That is equal to minus 9 divided by x square. That's what you'll get. Okay. So we can write it like this: df by dx minus 10 upon x and f of x. And that is equal to minus 9 by x square. Let's call it equation number 1. See, this equation is a linear differential equation. Its form is of this form: dy by dx plus p of x and y is equal to q of x. It is of this form. So we know that for this we define integrating factor, which is equal to integration of p of x and dx. That is the integrating factor. So therefore, in place of p of x, we have here minus 10 to the power x. So we get here minus 10 and dx upon x. If you compare this equation with this one, you have in place of p of x minus 10 to the power x. So that I'll put here. So when you integrate it, you are going to get here minus e to the power minus 10 ln x. Okay, that's what we get. So let's write it here because I don't have much space. So we are getting here, see, when you integrate this, you are going to get here e to the power minus 10 ln x. So this is equal to e to the power ln x to the power minus 10. So this is x to the power minus 10. Okay. So that's the integrating factor that we have gotten. integrating factor. So now we know that solution of this type of equation, okay, solution of this type of equation is written like this. Suppose this is equation number 2. So solution of equation 2 is written like this: y multiplied by integrating factor is equal to here q of x multiplied by integrating factor and integration on x plus some constant c. So therefore here if we apply the same concept on equation 1, we will get here f, and integrating factor here we have is x to the power minus 10, that is equal to q of x. Here we have if you compare these two, you are getting minus 9 divided by x square, that is q of x, and integrating factor here is x to the power minus 10 and d of x, okay, plus some constant c. So we have here x to the power minus 12. So if you integrate it, you will get x to the power minus 10, that is equal to 9 by 11 and x to the power minus 11. So if you integrate it, you get this plus some constant c. Now it is given that at x equal to 1, we have function is equal to 2. That is given here. You see this information. So if you put x equal to 1 here and function equal to 2, you will end up getting here. Let's complete it in this slide itself. So you will get here something like this. We are putting f equal to 2, so you will get 2 here. Let's call it equation number 3. Okay. So f equal to 2 and x equal to 1, so we will get here 1, and this will become 9 by 11. Okay, and plus some constant c. So bring it to this side. It is 2 multiplied by 1, so this is basically 2. So 2 minus 9 by 11, and that is equal to c. So c is equal to, this is 13 by 11. Okay. So we have gotten c equal to 13 by 11. So let's put that into equation number 1. So we will get here, let's write it like this. So I'm writing it with a different color now. So let's write like this: f x to the power minus 10, that is equal to 9 divided by 11 and x to the power minus 11, and plus we have put c equal to 13 by 11. You see here. So this c I have put into equation number 3. Now multiply both sides by x to the power 10. So if you multiply both sides by x to the power 10, you will get f. And here, since there is x to the power minus 11, so when you multiply by x to the power minus 10, you will get x to the power minus 1 here. So that is 9 and by 11x, and plus here you will get 13 by 11 and x to the power 10. That's what you are getting. Okay. So you see here, this is the B option that we have obtained. Okay. Here 9 by 11x and 13 by 11 and x to the power 10. So we can say that B option is matching. Okay. You can solve this question by doing Taylor series expansion of the function also. Okay. Or you can solve this question by putting the options in this term and checking whether you are getting one or not. Okay. So these are some other ways to do this question. Okay. So that's all in this video. See, in this channel, I'll be mostly discussing IIT JEE level mathematics and physics questions, and I will also be discussing some Olympiad level physics questions. Okay.